Okay, so good morning, good afternoon, good evening. So, welcome to my channel. So, for today's video, I was actually going to make, supposedly, I was going to make a video for the oops, uh, derivative of chain rule, derivative of exponential and logarithmic functions. But I do not have time to make that video. So instead of making a video, I will just live stream na lang so that you can have an example for this topic. So I think we can already start. So you may watch this. By the way, this is recorded. So I'll just post the VOD, the VOD later on in oh yeah, I will post it later. So let's start with the examples. Where is my... Okay, so... Okay, so we are now in chain rule for derivatives of logarithmic and exponential functions. So for my students, you can refer these examples. Use this as reference for your workbook activity 16 and 17. So let's start with logarithmic functions first before we proceed to exponential functions, because I think the workbook starts with logarithmic logarithmic functions, then followed by exponential functions at activity number 17. So let's have this example. The natural log of 2x plus 1 raised to the power of 2. So in this scenario, if you try to look at the given, 2x plus 1 here is raised to the power of 2. It is not the natural log itself. Hence, we are going to apply chain rule in 2x plus 1, not in the natural log. So again, the chain rule happens in the argument, or in other words, in the parentheses, not in the natural log. So, this means that we will apply the differentiation rule for ln of u. So if you try to remember the derivative of... So in my previous video, I will just repost the link later on at the end of this video for the previous differentiation rules. So the derivative of ln of u, or the natural log of u, is just 1 over u times the derivative of whatever is your argument. So du over dx, or derivative of u with respect to x. So in this scenario, our u is 2x plus 1. It is not just 2x plus 1. It is 2x plus 1 squared. So that's why here we have 1 over 2x plus 1 quantity square. Okay? So then we get the derivative of the argument. So in this scenario, the argument is 2x plus 1 squared. So here we apply chain rule. So we put 2 first, so times 2, followed by 2x plus 1 raised to the power of 2 minus 1, because it's chain rule. And then lastly, we get the derivative of the innermost function, which is 2x plus 1. So the derivative of 2x plus 1 is just 2 times 1 plus 0. So if we simplify this, we can multiply 2 times 2 here, because syempre 0, it's just 0, so we can disregard that. So this is just 2. So 2 times 2, we have 4. And then 2x plus 1 raised to the power of 1. So we will get something like this. And then observe that we can cancel out 2x plus 1 here, because they are just the same terms, the same factors rather. So cancel out 2x plus 1 here. This one is also cancelled out, so we have 2x plus 1 in the denominator. So for the final answer, we have 4 over 2x plus 1. Okay. Wait. Okay, so let's have the next example. For the next example, we have the natural log of secant of x. So in this scenario, our u is secant x. So using the same formula, so derivative of ln of u, so which is just 1 over u times du over dx. So we have here 1 over secant of x. Then times whatever is the derivative of secant of x. So take note, the derivative of secant of x is secant x tangent x. So that's why here we have times secant x times tangent x. And of course, the derivative of the angle, so derivative of x is just 1. So it's from the outermost, which is the natural log ln, followed by the derivative of secant x, and then lastly the derivative of the angle. So it's still almost similar to the derivative of trigo function, diba? So outer, inner, then last would be the angle. So observe that we can cancel out secant x here. So we have just tangent x times 1. So the final answer would be tan x. Okay, for a while lang. Okay, so let's have the next example. So for the next example, we have here the natural log of 2x all over 2x squared minus 4. So by observing the given, it's very obvious that we are going to use quotient rule. So remember quotient rule. So if we have derivative of u over v, I'm sorry, I'm just using mouse. I don't have my pen. My pen is already it's surrendered already. So we have v times du minus u times dv over v squared. So in this case, our u is 2x, our v is 2x squared minus 4. So let's apply first the derivative of the natural logarithm. So that's why here, okay. By the way, we can still simplify further. We can factor out, for a while, we can factor out 2. I'll just change something first, because there is an error. So derivative of, so it should be 2, not 4. For a while lang. Okay, so sorry for the delay. I'm just fixing something. Okay, so that should be 2. Okay, so we can cancel out here 2 because we factor out 2. There's a common factor in the denominator for... I'll wait for a while. No, this is not correct also. Sorry, there should be ln. I forgot the ln. I forgot to type the ln. Okay, again. Ay, nako. Okay, so here, uh, instead of having 2x all over 2x squared minus 4, we can simplify further so that it's much easy to solve. So we can factor out 2 in the denominator. So factoring out 2, we can cancel out 2. So this will just give us ln of x over x squared minus 2. Okay? So by using this, so it's much easier to solve. So instead of having 1 over 2x squared minus 4, we now have 1 over x squared minus 2 because it's 1 over u. The derivative of ln is 1 over u. Oh yeah, for my students in the activity 16 and 17, no need to show your solutions. Okay, so next, we get the derivative of the inner function. So the inner function, which is the argument, is x over x squared minus 2. So we will just use v du minus u dv over v squared. So this is u, this is v. I'll just erase this one first. So we have times, so x squared minus 2, because just copy, it's v, then du, derivative of x is just 1. Then we have minus u dv, so u is x, then times the derivative of x squared minus 2 is just 2x minus 0. And then lastly, we have v squared in the denominator, so our v is x squared minus 2, so that's why we have here quantity of x squared minus 2 squared. Okay, so simplifying this will give us, so of course we can get the reciprocal of this. So that's why we have now x squared minus 2 over x instead of having this. So then we simplify further the next factor. So we just distribute. So that's why we have x squared minus 2 minus, so x times 2x is just 2x squared. Never mind the 0 again. And then lastly, we have, of course, over x squared minus 2 quantity square. Then observe that this is just the same factors. The difference is just that this is squared. So this means that we can cancel this one out. So this becomes x squared minus 2 raised to the power of 1. And then we can simplify this, x squared and negative 2x squared. So this is cancelled, and then of course what remains here is just negative x squared. So that's why we have here, so I just wrote the negative x squared here. So we have 1 over x times negative x squared minus 2 all over x squared. And then simplifying further, take note, we can factor out the negative. So that's why I wrote the negative here. Then this becomes positive x squared, and this becomes positive 2. And then x in the denominator of 1 over x will be distributed to x squared. That's why it becomes x cubed here. And then here, x is being distributed to negative 2. That's why we have here negative 2x. So that could be the final answer. Yeah, I think this is already the final answer. We don't have any more. We don't have any factors to simplify further. Okay, let's have the next example. So for the next example, let's have this log to the power of 3 of log to the power of 3 of 3x plus 1. So take note, we can hello. Okay, so take note that this can be rewritten as log to the base 10 of 3x plus 1 to the power of 3. So because again, if there's nothing written in the base of log, it means that the base is 10. And then of course, this 3 here is actually the exponent of the entire logarithmic function. So again, we can rewrite this one to this. Then this one will be our basis for the derivative. So before we get the derivative of logarithm, we're going to use chain rule first. So unlike in the previous example, I think the first example where we get the derivative of the logarithm first, here we get the derivative of the chain rule. So we apply the chain rule first before we apply the derivative of logarithm. So we write first, so bring down 3. Then of course, log, so again, this is just the same as this. So we have 3 minus 1, and then copy. So that's for the derivative of the outer function. Next, we get the derivative of the inner. So we can now apply the derivative of the logarithm. So we have times here 1 over, so of course our u is 3x plus 1. So 1 over 3x plus 1 times ln of a. So again, our a here is the base. The base is 10. So that's why we have here ln of 10. Okay. So after this, we get the derivative of the argument, the innermost function. So getting the derivative of that is just 3 times 1 plus 0. So meaning this is just 3. Okay. So we simplify further. So take note, this cannot be cancelled out, ha? It's because this is an argument, this is not an argument. So be careful. So we just combine. So here we have 3 times 1, which is just 3. So 3 times 3 here, we can have 9. So that's why we have something like this. So 3 times 3, then we just combine further. So we have 9 here. And then we have log to the power of 2. Of course, because it's 3 minus 1. And then 3x plus 1, the argument, all over. So take note, we can actually write it in this manner or in this manner. Does not matter. Kay, it is, since it is commutative. But I just wrote it first because ln of 10 is a constant. Just for standard purposes lang. Constant should be written at the first part. So, we have here 9 log to the power of 2 of 3x plus 1 all over ln of 10 times the quantity of 3x plus 1. So again, we cannot cancel out this one because 3x plus 1 is an argument here for log. Then in the denominator, 3x plus 1 is not an argument. It's just an algebraic expression. So, since we cannot cancel out anything, this is the final answer. Okay, so next example. So let's have a logarithmic function with a radical argument. In this case, square root of 2x minus 1. So we have log to the base of 4 of square root of 2x minus 1. So, we can rewrite this one as log to the base of 4 of 2x minus 1 raised to the power of 1/2. Because again, square root is just a fractional exponent with 1/2. So we apply first, in this scenario, we apply first the derivative of logarithms before we apply chain rule. Because again, 2x minus 1 here is raised to the power of 1/2 and not the logarithm. So applying the derivative of logarithm first. So take note, the derivative of log to the base a of u is just, it's almost the same with ln of u. It's just 1 over u, but we have an extra ln of a. And then times the derivative of du over dx. The argument. Derivative of the argument. So that's why we have here 1 over ln of 4. So by the way, I just wrote again ln of a first because this is a constant. So we have ln of 4, which is this part here. Then we have our u is 2x minus 1 raised to the power of 1 half. Okay? So, continuing our solution. So, next would be the derivative of u. So, in this case, we will apply chain rule. So, we write first 1 half. Then we have 2x minus 1 raised to the power 1 half minus 1. So, then we get the derivative of the innermost function. The argument, the innermost, which is the 2x minus 1. So, derivative of 2x minus 1 is just 2 times 1 minus 0. Or simply 2. Okay, so observe that we can cancel out 2 here, diba? Because we have 1 half here. So what remains, okay, so it's just written, but it will be cancelled out later on. So here, okay, so what remains is 2x minus 1 raised to the power of negative 1 half ln of 4 times 2x minus 1 raised to the power of 1 half. So take note, these are just the same factors. So, I can combine this. If I combine this, if I use laws of exponent, we will get something like this. So, we have 1 over ln of 4 times 2x minus 1 raised to the power of 1 half minus, because, again, reciprocal, we apply the reciprocal of 2x minus 1 to the power of negative 1 half. So, we have minus negative 1 half. So, basically, it's plus 1 half. It becomes plus 1 half. So, 1 half plus 1 half is just 1. So, that's why for the final answer, we have 1 over ln of 4 times 2x minus 1. So, this is the final answer. Okay, so I'll proceed to the next example. So, you can, later on in the VOD, you can go back. I have already posted also in the, if you look at the description, the slides are already in the, the slides are already in the description. There's just an error yata. I'll just correct it later on after the stream. Okay, so let's proceed to the next example. Let's have here log to the base 2 of 5 to the power of cos x. So we have multiple chain rules here. So again, in this scenario, we apply logarithm first, because again it's 5 to the power of cos x. It's not the log which is raised to the power of cos x. It's only 5. There is no parenthesis. If it's like this, then it's different, but we don't have like that, so we just use this. So we have 1 over 5 to the power of cos x. Then again, the base is 2, so we have ln of 2, or again we can write ln 2 first before 5 cos x. Then times the derivative of 5 cos x, which is 5 cos x times ln of a. So our a is 5. In this scenario, a is the base of the exponential function. That's why we have here ln of 5. Okay, and then lastly, we have the derivative of the exponent. So derivative of cos x is just negative sine x. So that's why here we have times negative sine x. Then lastly, the derivative of the angle is just x. So that's why we have here times 1. So again, derivative of the log, which is this. Derivative of 5 cos x, which is this. Derivative of cos x, which is this. And lastly, the derivative of the angle, which is this. So we get the derivative 4 times, or in a 4 process. So let's see if we can simplify further. So take note, we have 5 cos x here and here, so we can cancel out this one. What else? Yeah, we cannot cancel it out anymore. So basically, for the final answer, we have ln. If I multiply ln of 5 to 1, we have ln of 5. And of course, we have a negative sign here. So negative, that's why we have, we have a negative here. Okay, so for the final answer, we can have this. Negative of ln of 5 over ln of 2, so times sine x. So by the way, we can also write sine x in the numerator, but since ln of 5 over ln of 2 is a constant, that's why it's written like this. So we can have this as our final answer. Or we can actually use also the change of base. So take note, change of base, if we have log of the same base, let's say log of a of m, log to the base a of m over log to the base a of n, this is just the same as log to the base n of m. So in this case, they have the same base, because ln, the base of ln is e. So we can rewrite this one as log to the base 2, because again, our n here is 2. Our m is 5. So we have negative log to the base 2 of 5 sine x. So we can also have this one as our final answer. Okay, so let's proceed to the next example. For the next example, let's have this. 1/2 of e to the power of sine of 2x. So for this scenario, 1/2 is just a constant. So we just write 1/2 first. And then we get the derivative of e to the power of sine of 2x. So the derivative of e to the u is just e to the u. So derivative of e to the u is just e to the u. Okay, so times du over dx, of course. The derivative of the exponent. So for exponential, it's not anymore the angle, it's not anymore the argument, it's the exponent. So that's why here we have e to the power of sine of 2x. So it's just, you just copy and paste the given. E to the power of sine 2x. Then afterwards, get the derivative of the exponent. So in this case, our exponent is sine of 2x. So derivative of sine is cosine. So that's why here we have cos 2x. And then lastly, the derivative of the angle. So derivative of 2x is just 2. So we can cancel out 2 here because we have 1/2. So for the final answer, it's simply e to the power of sine of 2x times cos 2x. Or we can rewrite it as cos 2x times e to the power of sine 2x. So by the way, you can actually use dot for multiplication, or you can also use parentheses. If you don't want to use that, you can also write it in this manner. Okay, so let's go to the next example. So for the next example, let's have this. I think this is one almost similar to a number in an activity in the workbook. I think workbook 16, activity 16. So in this scenario, we have 3e to the power 1 over 4x raised to the power of 2. So it's obviously that the outer function must be processed first. So get the derivative of this. So we write 2 first, copy, and then subtract 1 to the exponent. And then get the derivative of the inner function. So for the inner function, we have 3. 3 is just a constant, so that's why we just write 3 first, followed by the derivative of e to the power of 1 over 4x. So derivative of e to the power 1 4x is just e to the power of 1 over 4x, followed by the derivative of the exponent. So derivative of the exponent, we are going to apply quotient rule. So that's why we have here, so v is 4x, so 4x du, derivative of 1 is just 0, minus u, so u is 1, times dv, derivative of 4x is just 4, all over quantity of 4x squared. Okay, so let's see if we can simplify further. So of course, this is just 0. For x times 0 is just 0. So we can multiply first. Sige. So we multiply first 2 and 3 here. But again, we can multiply the constant if you can see it already. But let's just do it one step at a time. So 2 times 3 is just 6. So we get 3 times e to the power 1 over 4x times e to the power 1 over 4x times. So of course, here we have negative 1 times 4, which is just negative 4. Then we have over 16x squared. So if we observe this one, we can simplify 4 over 16. So this becomes 4. And then we can multiply 6 and 3 here, so which is 18. And then of course, since they have the same base, we can add their exponents. So 1 over 4x plus 1 over 4x is 2 over 4x. So again, 6 times 3 is 18. Then 4 over 16 is 1 over 4. And then 1 plus 1, we have here 2 over 4x. So we can still simplify further. So 18 and 4, common factor is 2. So 18 divided by 2 is 9. 4 divided by 2 is 2. And then here, this can be just 1 over 2. So 1/2, 1 over 2x. So we will have something like this. And then lastly, we just combine further. So for combining further, so we'll get negative 9e to the power 1 over 2x over 2x squared. And since we cannot actually write an answer with fractional exponent, we can use radical. We can use radical. So we have 9 2x root of e. Sorry, I forgot the negative. Negative 9 2x root of e all over 2x squared. So this will be the final answer. Okay. Next example. How many examples more? I think I have a lot pa. Ilan pa ba to? How many? Okay, so just a few more na lang. Okay, so let's have this as the next example. So we have here 3x plus 1 times e to the power of 4x. So there are two ways of solving this. We can simplify first and then just apply the sum and difference rule for differentiation, or we can also apply product rule. So in this scenario, I will use product rule. So product rule, if we have the derivative of u times v, v, we have u dv plus v du. So following this formula, our u would be 3x plus 1. Our v will be e to the power of 4x. So that's why we write first 3x plus 1 followed by the derivative of e to the power of 4x. So derivative of e to the power of 4x is just e to the power of 4x times the derivative of its exponent, which is 4. So simplifying further, sorry, I forgot. That's u dv plus v du. So v is e to the power 4x times the derivative of 3x plus 1, which is just 3. Diba? Kaya it's 3 times 1 plus 0. So, okay, so we distribute here. This one, we distribute. So, e to the power 4x times 4 to 3x is just 12x, e to the power 4x. Then e to the power 4x times 4 times 1 is just 4, e to the power 4x. And of course, just rewriting this part here, rearranging, so we have this. Then what else? Yeah, we can add this one. So adding this one for e to the power 4x, because they have the same variables, or in this case the same factors. different numerical coefficient. So that will give us 7e to the power 4x. So this can be the final answer. Or you can actually factor out the common factor, e to the power of 4x. So for that, we can have this as final answer. So factoring out e to the power 4x. So we have e to the power 4x times the quantity of 12x plus 7. Okay, next example. So what if we have a quotient or a rational function with exponential functions? So we have 2e to the power of x minus 1 all over 2e to the power of x plus 1. So again, we can use v du minus u dv over v squared. So our v is 2e to the power of x plus 1. Then derivative of u. So derivative of this, so just copy the constant. Derivative of e to the power of x is just e to the power of x times 1. Because x is the exponent, derivative of x is 1. So minus derivative of 1 is 0. E to the 12e to the power of 4x for a while ha. Sorry, I read the comments late. We're here. Hi sir, pwede balikon explain 12e to the power of 4x. So again, in this scenario, our u is 3x plus 1. Our v is e to the power of 4x. So our formula is u dv plus v du. dv plus v du. So u is 3x plus 1. dv, derivative of e to the power 4x, is just e to the power 4x times the derivative of its exponent. So its exponent is 4x. Derivative of 4x is 4. So again, for e to the power of u, just copy the given, then times the derivative of the exponent. So that's u dv. Next, plus v du. So our v is e to the power 4x. This is v. And then derivative of u. So derivative of 3x plus 1. Derivative of 3x is just 3. Derivative of 1 is 0. So 3 plus 0 is just 3. So this is du. Okay. So we rearrange. We distribute if we can distribute. So in this scenario, we distribute e to the power 4x times 4. So if I multiply it in this part, sa 3x, so 3 times 4 is 12. So we have 12x. And then e to the power of 4x. So we have it here. Next, distribute this again to 1. So we will have 4e to the power 4x. And then of course, this one, just rearrange. So we have 3e to the power 4x. Okay, then this one, they have the same factors, e to the power 4x. So we can add 4 and 3. 4 plus 3. So that's why we have here 7e to the power of 4x. So this can be the final answer. But again, since they have common factor, diba? They have common factor. So we can factor out e to the power of 4x. So what will remain will be 12x for the first term. And then of course here, so plus 7. So that's why here, we can also have this as an answer. E to the power 4x times 12x plus 7. Nakuha ba? Okay, I hope nakuha ra. So I hope you got the solution. So just just play it back later na lang. Or read the slides later. Okay, so let's proceed to the next example. Where are we? I'll just explain again. So again, it's v du. I'll write the formula here. v du minus u dv over v squared. So our v is 2e to the power of x plus 1. This is v. Then our u is 2e to the power of x minus 1. So that's why we write first v, 2e to the power of x plus 1, followed by du. So derivative of u, so we just copy 2 first because it's a constant or numerical coefficient in this scenario. And then we get the derivative of e to the power of x. So derivative of e to the power of x is e to the power of x, followed by the derivative of its exponent, which is 1. So that's why it's times 1 here. Minus derivative of 1. Derivative of 1 is 0. Okay, so that's v du. Minus u dv. So u is 2e to the power of x minus 1. And then we get the derivative of 2e to the power of x plus 1. So we just copy 2 because it's a constant, a numerical coefficient in this scenario. Then derivative of e to the power of x. So e to the power of x times the derivative of x, which is 1, plus derivative of 1, which is 0. Okay? So all over v squared. So v squared, we will have 2e to the power of x plus 1 raised to the power of 2. So next step would be to simplify or rearrange or cancel out, if we can cancel out something. So of course, we just disregard 0. Never mind the zeros here. So actually, never mind the 1 also here. We just have 2e to the power of x and also here. So we distribute 2e to the power of x. We can distribute them. So if we distribute 2e to the power of x in the first factors, we will get 4e to the power of... So it's 2x. It's because x plus x. You add the exponent. Remember, when you multiply x to the power of 1 times x to the power of 1, it becomes x squared. So it's also the same here. E to the power of x times e to the power of x is just e to the power of 2x. Then distribute 2e to the power of x to 1 here. So that's why we have 2e to the power of x here. And then for the next one, so we have 2e to the power of x times 2e to the power of x. We have 4e to the power of x also here. But take note, there is a negative sign here. So we also distribute the negative sign. So that's why we have negative 4e to the power of 2x here. And then lastly, 2e to the power of x times 1. So that's why we have 2e to the power of x here. But again, we distribute the negative sign to the negative sign here. So that's why we have positive here, plus. Okay, so let's simplify further. I think we can combine. Yeah, we can combine here. So 4e to the power of x minus 4e to the power of x, it's just 0. So that's why this will be cancelled out. And then we have 2e to the power of x plus 2e to the power of x. We have 4e to the power of x. Okay, all over, of course, just copy the denominator. And this is the final answer. Okay, let's have the next example. So let's say we have here 1 over 5 times 3 to the power of 2x minus 3. So it's an exponential, but we have it's not anymore e, it's any constant. So again, 1 over 5 is just a constant, a numerical coefficient. So para you will not be confused. We will just call it numerical coefficient. So if you have a numerical coefficient, just write the numerical coefficient. Copy the numerical coefficient. So 1 over 5. And then the derivative of this. So take note, the derivative, I'll just write the formula somewhere here. The derivative of, derivative of a to the power of u, a means any number, any constant. It's just this, it's almost similar to the e to the power of u. You just copy the given first, a to the power of u, but you will write ln of a. And then we have du over dx. Okay, so let's follow this formula. So let's copy 3 to the power of 2x minus 3. And then we have ln of whatever is the base. So our base is 3, so ln of 3. And then times the derivative of the exponent. So that's why we have 2 times 1 minus 0. So again, we can take out 0. Just say it's just 2. Okay, rearranging this. So we'll get, so since this is 2, again, this is just 2. 2 times 1 over 5 is 2 over 5. And then we rewrite ln. Since ln of 3 is a constant, there is no variable here. So I just put ln of 3 here. So again, we can use dot or parenthesis indicating multiplication. And then we write the last term, 3 to the power of 2x minus 3. And this can be the final answer. Okay, let's have this. What if we have two exponential functions being multiplied? So we have 2 to the power of 3x times 3 to the power of 2x. So since this is multiplication, we apply product rule. So we have u dv plus v du. So in this case, we have u as our 2 to the power of 3x as our u, and then 3 to the power of 2x as our v. So again, it's u dv plus v du. Okay, so we copy first 2 to the power of 3x, then get the derivative of 3 to the power of 2x, which is just 3 to the power of 2x, ln of the base 3, and then times the derivative of the exponent, which is 2. So that's dv. Again, derivative of 3 to the power of 2x is just copy the given, 3 to the power of 2x, times ln of whatever is the base here, which is 3, times the derivative of the exponent, 2. So plus v du, so v is 3 to the power of 2x times du. So we're going to copy the given, 2 to the power of 3x, ln of 2, because this is not e anymore, it's any number. So we have 2 to the power of 3x, ln of 2, times the derivative of the exponent. So what is the derivative of 3x? It's just 3. So take note, you cannot multiply 3 to ln of 2 and 2 to ln of 3, ha? This is ln of 3. This is ln of 2. So we can only multiply the constant with another constant, but not with ln of 2 and ln of 3. Okay, so if you try to observe, we have a common factor here. Both terms, this term and this term, diba? So two terms na jud ni sila. They have two terms. So they both have this 2 to the power of 3x times 3 to the power of 2x. And also this, it's just disarranged, diba? They both have 2 to the power of 3x and 3 to the power of 2x. So this means that we can factor 2 to the power of 3x times 3 to the power of 2x. So we can factor out. So what will remain? We have ln of 3 times 2. So again, you cannot multiply 2 to 3 because this is ln of 3. This is an argument. It's like an angle. So for trigo function, we have the angle. Here, we have the argument. The argument of the natural log here is 3. So you cannot multiply 3 to 2. So that's why we write it as this, 2 ln of 3. And then we have plus this, ln of 2 times 3. So again, you cannot multiply 3 to 2. So that's why we just rearrange. We have 3 ln of 2. So this is the final answer. Okay, so just ano lang, rewind later on. Okay, so let's have this. What if we have this one? Okay, now, observe that our given is x times 2 to the power of 2x times 2 to the power of 3x. Take note that the bases are the same. We have 2 here. So this should indicate that we can combine this and this. So remember, if we have x to the power of m times x to the power of n, it's just x to the power of m plus n. So meaning we can add 2x and 3x since they have the same base. So that's why instead of solving it, we cannot apply product rule first here, diba? Because we have 3. We can only use product rule if we have 2 factors. So that's why we need to combine. So we have x times 2 to the power of 5x. We just add 2x and 3x. And this can be solved by product rule. So our u is x, our v is 2 to the power of 5x. So this should give us x times the derivative of 2 to the power of 5x is just 2 to the power of 5x times ln of 2 times the exponent. The derivative of the exponent, 5x is just 5. So that's u dv plus v du. So v is 2 to the power of 5x. Okay, v, then derivative of x is just 1. Okay, so take note, common factor is 2 to the power of 5x. Okay, so before I show this one, common factor is 2 to the 5x. So we can factor out. So what will remain? We have x ln of 2 times 5. Again, you cannot multiply 5 to 2 because 2 is an argument for ln. So we just rewrite it as 5 ln of 2, diba? But we have x man. So we have 5 x ln of 2. Okay. Plus, so we have a plus sign here. Then of course, if we factor out 2 to the power 5x, what remains is just 1. And this is the final answer. Okay, so that's the end of the examples. Okay, so just check na lang for the video, the VOD later on as a guide for activity 16 and 17 for my students. Any questions? Okay, so I think we don't have any more questions siguro. I'll wait for siguro 1 minute. Okay, by the way, thank you for being here, for those who really wait for the live sessions. But again, you can watch this later on. Since it's also my fault, I just got back from the province also due to the long holidays, so I was not able to make the video. I don't have the proper equipment there. Okay, so see you in the next video. Keep calculating. Bye bye.